Hi algebra students, this is our introduction video for our lessons on patterns of growth. The focus of this lesson is going to be describing patterns we see in tables, specifically linear tables and exponential tables. In order to look at those patterns, we're going to talk about these two stories here. We've got our first one, Lulia plants a 3-foot tree in her backyard. Every year it grows another 2 feet. The first thing we're going to do is we're going to create a table for this situation. Remember, when you create a table, that first column is always your input, and then the second one is always your output. You could also say independent variable and dependent variable. Here, though, our input is going to be the number of years, so that will go in this first column, and then the second one would be the height of the tree, and we could even say like height in feet. So for example, we are starting year 0 with a tree that is 3 feet. And then after 1 year, the height of that tree, it's growing 2 feet. And so that height would be just 2 more feet, which would be a total of 5 feet. Go ahead and complete this table for year 2, year 3, year 5, and year 10. Pause the video and come back when you've got those numbers. So there's 2 ways you can fill in this table. Our pattern is growing another 2 feet every year. So one way we could do this is keep adding 2 feet every single year. And so that means year 2, it would be 7 feet. Year 3, it would be 9 feet. And then that pattern doesn't help as much when we start jumping years. Another way you can do this is thinking about a math expression you could use to get the height for any number of years. So for example, for after 2 years, we are starting at 3 feet, and it's growing 2 feet every year, and it's been 2 years. And so by doing the math that way, 2 times 2, it means it's grown 4 feet plus 3 gives us 7 feet. And I can keep doing that for these others. And then when I get to year 5, it's not a big deal. If I start skipping some years, I know it's starting at 3 feet and it's growing 2 feet every year for 5 years. And that gets me to my 13. After 10 years, it starts at 3 feet and it grows 2 feet every year for 10 years, which gives me 23 feet. One of the things we're going to look at in this lesson is the patterns we see in tables like these. So the pattern here specifically is this pattern of addition. We are adding 2 every single year. There's a second story. We've got a fire starts in Hoosier Forest. It initially covers 2 square meters of land and triples in size every minute. Again, I'm going to set up my table with my input, which is the number of minutes first, and then the square meters of land is our output. So square meters of land. So just like we had done here, we are going to start at minute 0, and our fire starts by covering 2 square meters of land. After 1 minute, what happens? Well, we are told it triples in size. That word triple means we are multiplying by 3. So after 1 minute, we multiply by 3, and we've got a fire that is 6 square meters. We can do that 2 times 3 to get that answer. After 2 minutes, it has tripled in size again, and so we've got 6 times 3, that gives me that 18 square meters of land. Same as before, go ahead, pause this video and do 2, 3, 5, and 10 for this problem. So just like before, we can continue to use that pattern to help us get some of these numbers. It's tripling in size every single minute. So after 3 minutes, it just means I am tripling that 18 square meters, which would be 54. Or we can do what we were doing over here and come up with an expression to help us find these answers. That's going to be really important when we get to minutes 5 and minute 10 when we've skipped some. So going back to minute 2, a way we could write our expression is saying it's starting at 2 square meters, and after 2 minutes it is tripled twice. So I could say after It starts with 2, and then after 2 minutes, it's tripled once, it's tripled twice. Now, if I keep doing that, when we get to minute 10, I'm going to have a lot of multiplication, so the other way we can write that is using that exponent. And then when I have a problem like this, 3 squared is 9, and 9 times 2 gives me 18. When we get to minute 3, the same idea. It starts with 2 square meters, and it is tripling 3 times. That gives me 27 times 2, which is 54. So then when I get to minutes 5 and minute 10, I have 2 times 3 to the 5th power and 2 times 3 to the 10th power. I know that final one, you get a really big number, 118,098 square meters of land. The focus of this lesson, we said, is all about patterns we see in tables. We noticed this first table here had an addition pattern. This table has a multiplication pattern. And it is that pattern we use to help us identify what type of relationships we have. Yesterday we learned if you have this addition pattern, if something's growing by adding the same number again and again and again, it is a linear relationship. This table here, though, is different because the pattern is multiplication, and if you have this multiplication pattern, it is an exponential relationship. And so we can use those to help us identify patterns in our tables, create tables, and also create expressions like this to help us describe different information. Our lesson today is going to look at problems similar to this and how we can use these patterns to help us understand tables. Thanks so much for watching.